Normal force, it is perpendicular to the surfaces of contact. So right now, the floor is pushing up on me, I'm pushing down on the floor. It's perpendicular, it's going up and down. As I lean against the wall here, the wall is pushing on me that way. I'm pushing on the wall that way. Hope the change in room didn't mess you up too much. I made it. Welcome. And the gravitational force is toward the other object's center of mass. So the force that I exert on the Earth is towards my center of mass. The force the Earth exerts on me is towards the center of mass of the Earth, which we will assume is in the middle of the Earth. All right. Dramatic pause for questions before we get to our first force diagram.
Did I say perpendicular to the surface of the contact?
Yes. Surfaces, I don't know if you threw in the extra S. There are two surfaces that are touching each other, the surfaces of contact. So we've set up the rules, now we need to apply them. And the first one is going to be the always exciting box falling. I know, we get to do that. Box falling. All right, we will start over here. Whenever you see the hash marks like this is indicating that you have something that we are assuming is not moving. Box. Falling. We're ignoring air resistance, but I can put a little air streams in there to somehow give some indication that it's falling. All right, so when doing a force diagram, the first thing you do is you draw the two objects so they are separate from each other. Now in this case, they're already separate, but I'm still gonna draw them separately. I'm gonna draw my box right here, and I'm gonna draw my ground. And the reason why I'm doing it here, even though I've got plenty of space over there, is just to try to develop the habit. Got way too many force diagrams where people try to cram arrows. Well, we'll get to it when we do box on ground. All right, so now we go through the list. We are ignoring air resistance. Is there any friction involved?
No.
Okay, because contact's required, so no friction. Tension. Other? Did I mention any mysterious force involved in the problem? Normal. Gravitational force.
Yes.
All right, so there is a weight involved here because I got two masses. I got a planet and I have a box here. What is the direction of the force acting on the box?
Upward? No.
So the Earth is pushing up on the box?
No, the air is my bad. Pushing down.
Yeah, or pulling down. So there's this force acting down on the box, and I'm going to put a little W there to indicate it's the weight of the box. But forces come in pairs. So where's the other force in that pair? From the ground? This is what I get picky about the prepositions used. Where would you draw it?
Pushing like up from the ground.
So where do I draw my arrow?
I would do from,
Then tell me on what do I draw my,
never mind, that was
where would you draw it? Here or here?
on the ground.
Okay, and this is, some people wonder why I get picky about this. If you can say it properly, you can draw it properly. That's my theory. It is the force acting on the ground. So there's a force acting upwards on the ground, so I draw my arrow up on the ground. Technically, that's the force from the ground. This is the force on the ground. It is the same magnitude, so I put a little W there, the same W that I had before. Because those forces are equal. Another way that we can, equal in magnitude. Another way we can indicate they're equal in magnitude is draw the arrows the exact same length. However, I'm using my label instead because I probably can't draw them the exact same length. Any questions? All right, this is the first one. I know, it's gonna get even more exciting, and hard to believe, but it will get more exciting than this. All right, first off, some rookie mistakes. Rookie mistake number one. No man's land. I've seen it way too many times. I don't know what the student's intent is. Which force is acting on which object? They sort of draw it somewhere in this nebulous no man's land. Now, if they drew it like that, I think I have a pretty good idea of what they're doing. That I can handle. But this, side by side, I don't know what the student is thinking. So, probably circle it and write something like that, which means ignore. I'm going to pretend it's not even there. Rookie mistake number two. Backwards. It's like saying the earth is pushing up on the box is pushing down on the ground. It's very difficult to push down on the ground without touching it. But for both of these, let's go ahead and do the circle. Mr. Yuck sticker there. Yeah, don't commit these errors. All right, sorry, flashing back. Questions? Now we'll go into the next exciting installment, box on ground. So first, I draw the picture of what's going on here. As a box sitting on the ground. Cover how I came up with that title. For box on ground, just recognize that if it looks like it's supposed to be a flat ground, then assume it is. If in doubt, please ask, but I'm not going to play a game where I go, you missed, it was at a 1 degree angle. No, I don't play that game. It'll be obvious if it's on the slant. It should be obvious. All right, so first thing I do, I'm going to draw my two objects so they are separate. I recommend that you draw them in the same basic orientation, that I have a ground and I draw the box. I'm not saying the box is in the air. All I've done is I've drawn a box, I've drawn the ground, I've given myself enough room to draw arrows. I'll put down my checklist, F-tong. So are there any of these forces that we can eliminate?
Friction.
Yep. Why?
Because it's not moving.
Ooh, wrong reason. And the reason why not moving is not sufficient is if I tilt that, the stapler is not moving, but there's still friction acting on it, keeping the stapler from sliding down.
Other forces are stronger.
All right. Other forces being stronger doesn't necessarily mean friction's not there. But if this ground is level, which way would this box slide? If this were frictionless, which way would the box slide?
Has to have a desired motion.
That's the key there. There's no desire for it to move. So because it would not, there's no place for it to go. It's level ground. No friction because of that reason. All right. What else can we get rid of?
Other.
Okay. Why? Anyone?
Because you didn't explain any other forces, whether you didn't explain any abnormal or.
I didn't mention any other forces in thought. Yeah. The spirit was there. The words were slightly off, but all right. What else can we get rid of?
Tension,
Why?
because the forces aren't going out. Or,
What's
sorry.
what's the requirement for tension? Look at your notes if you need to. It's day one, so
The tide rotation, so it's not connected to anything.
yeah, nothing's pulling on it, which I think you were indicating before.
Yeah.
But, all right, so tension's gone. All right, normal force. Is there contact?
Yes.
Probably a normal force, but gravitational force?
Yes.
Yeah, it's near a planet. All right, so I'm gonna draw, let's do gravitational force first, since we've done that one already. So I got gravitational force acting down there, we're gonna call the weight, and I got the weight acting there, they come in pairs. Now normal force. Normal force is what keeps one object going through another. So if weight is the only force acting on the box, that box is gonna fall. But is the box falling?
No.
No. So there's gotta be something holding it up. That's the normal force. So there's a normal force acting up. And likewise, normal force pushing down. Rookie mistake, number 3. Mistake number 3 is drawing the forces here. Weight, let's say normal force, normal force. I can supply you paper if you're running short on paper, but please feel free to use the space. Free body diagrams are very similar to what we have right here. So typically in physics textbooks, they talk about the free body diagram instead of the force diagram. Matter of fact, probably they all talk about free body diagrams. The difference between free body and what I'm doing right here is a free body basically says, that's my box right there. And I got a force up and I got a force down. There's my Earth, there's my planet or whatever it is. Planet, I've got weight acting up and normal force acting down. The free body diagram typically is just, they reduce it down to a single point. My issue with that is my undergraduate degrees in engineering and where forces are applied becomes rather critical there. And so by drawing out the object instead of reducing it to a single dot, when we get into rotational motion, it's an easier transition. Anyway, that's my take on it. So this is, so when I say force diagram, this is what I mean. If you see free body diagram, this is typically what it's meant. All right. Questions before we do box on ground?
Are normal forces and gravity always opposing?
All right. First off, work on the language. Gravity is a huge topic of which we are talking about.
Or weight?
Okay, that's fine. No, they're not always opposite each other. They are a lot of times, especially early on, but later on, much less so.
Okay.
When we do box on ramp, that'll be an example where they're not opposite each other.
Okay.
And there's the, an object going around in a circle, like a roller coaster. At the top, weight and gravitation and normal force would be in the same direction in that case. Now the always famous box on ground. First, let me draw, in case you have no idea what a box sitting on the ground looks like. Ground, box, box. And I call the top one box A and the bottom one box B. If you'd rather do 1 and 2, that's fine, or alpha, beta, or Lucy and Ricky, whatever works for you. What's the first thing I should do when I'm doing a force diagram on these? So we draw the box A, box B, and ground. All right, now let's go down the checklist. What can we get rid of?
Friction.
Why?
Because there's no desired motion.
Okay, what else?
Tension,
Why?
because it requires like an object being stretched.
Okay,
Other.
why?
No other force is specified.
All right. Now we're down to the same two as we had before. Obviously, there's gonna be a slight difference than what we just did because we have 3 objects now. A, B, and ground. Sure, hit green, get pink, whatever. Let's do gravitation. I think gravitational force is the simplest personally, but it's however your mind is working at the time you need to use it. Tell me one of the gravitational forces, one of the weights.
Acting down on box A.
Right? Down on box A. So, okay. But they come in pairs. Where's the other one?
Up
Up
on.
on the ground.
Because that gravitational force is between the ground and A. Probably the most common mistake I see here is to put this up arrow on B. Gravitational force does not require contact. If the gravitational force were up on B, so you're saying that there's the gravitational forces between A and B. That means if I took B suddenly disappear, A would still hover there because B is no longer pulling down on it. So it's the ground. All right. Any other weights?
B to the ground,
Where am I drawing my arrow?
the bottom of the box, B to the ground.
That.
Now, just how you had it over there?
So I'm drawing it down on B or down on the earth?
On the earth. No, just how you had it over there?
How'd I have it over there?
Pointing towards the earth, but
Yeah,
not actually
point.
touching
But touching
it. But touching the box.
the bottom, okay. So down on B. And therefore, and where's the other part of that pair?
Up on the ground.
All right, there is a mistake with what I've done here. That's not gonna require you erasing anything unless you crammed everything into tight space. What is wrong with what I have drawn here?
You have 2 gravitational pulls on the Earth.
And? Right now, our class has 11 gravitational pulls on the Earth.
It's not specifying which gravitational forces for which box.
Do the boxes weigh the same?
No.
Unless it's specified otherwise, do not assume that the weights are the same, so we need to somehow differentiate the W's. Now, personally, I prefer a subscript that has some meaning to the object, so I would do this W sub A, W sub B. One of these at the bottom is W sub A, the other one is going to be a W sub B. And I should put the B next to the W there. Rookie mistake number, whatever we're up to, 4, no subscripts when they need to be there. We don't need subscripts over on the whiteboard over there because we have only one object beside the planet. I have only one pair of forces over there, but I have more than one pair of forces over here. Subscripts probably going to be involved. Now, some students, when they start doing their pairs, the first pair they put down, they'll label 1, next one they'll do a 2, and so on. Nothing inherently wrong with that. It's just, to me, it's very helpful for the subscript to have some meaning so that I don't have to go back and go, wait, where's 1, which one's 1? Which on this one would be simple enough, but when we get to the test level problem, it will not be. All right, gravitational force, done. Wrong one. Normal force. What is pushing on what?
Box B is pushing up on box A.
All right, box B is pushing up on box A, so I draw my arrow, it just says he said it, up on box A. I draw it up on box A, and put a little y sub A there. And they come in pairs though.
So down on box B.
Now I still have it y sub A because it's the same as this. I tend to, in things like this, I tend to start with subscripts at the top and work my way down. You could easily just have a y sub G down here and a y sub B here, just as long as they're somehow differentiated. And the other pair? One of the ones in the other pair?
Be down on the ground for box B.
Down on the ground, box B.
And up from the ground on box E.
All right. We're about to apply this information. Real life situation.